Hello, my name is Eric Monahan, and welcome to my video about Kamiak Butte. The contents of this video include the geologic foundations, including the landscape's history, the major floods attributing towards Kamiak Butte's formation, climate interactions, Kamiak Butte's biome, the landscape's physical characteristics, and the forest communities and wildlife within the landscape. The history of Kamiak Butte and the rest of the world's geologic foundations starts around 230 million years ago, when all of the Earth's continents were one supercontinent known as Pangaea. But around 200 million years ago, the supercontinent began to break apart and form the continental structure that is present today. Plate tectonics are a major contributor to how Kamiak Butte was formed. At one point, the Palouse region was over an oceanic plate. This is proven by the oceanic sedimentary rock found in the hills of the Palouse, such as quartzite, which is the bedrock for Kamiak Butte. The formation of Kamiak Butte is due to the oceanic plate being subducted beneath a continental plate that forced material to rise in the asthenosphere. Kamiak Butte is considered to be part of the Precambrian belt rocks. This means that new sediment was transported in and accumulated on top of older sediment in layers. And it is part of the Idaho batholith, which is one of the oldest formations and is primarily granite. You could observe the association because there are granite intrusions on Kamiak Butte. Another major attributor to the uniqueness of Kamiak Butte is the Columbia River basalt flood. This basalt flood covered around 130,000 square miles all across eastern Washington and parts of Oregon and Idaho. There were a couple major floods that affected the Palouse region and helped form Kamiak Butte and other similar landforms in the area. The Bonneville flood, which occurred first, and the Lake Missoula flood, which occurred shortly after. They both happened within a glacial period. The flooding of Lake Bonneville heavily affected the Snake River by deepening canyons and flooding the surrounding area and moving sediment. As the water moved through the Snake, it passed through the Palouse and especially Kamiak Butte. Lake Missoula occurred a short while in long-term thinking after the Bonneville flood. Although it was smaller than the prior megaflood, it still had a detrimental impact on the flood path. This flood was smaller and lasted much shorter, but it moved at great speed. The speed and amount of water that flooded eastern Washington from the Missoula flood was very detrimental to the environment. After these floods surpassed, different sediment and soils deposited all over the eastern side of Washington, creating the lowest soil that exists on the Palouse and Kamiak Butte. These floods had many negative effects, but also had positive effects that still exist to date. These are many of the few different climate interactions within Kamiak Butte that I will individually discuss. In North America, there are different air masses coming from every direction. The air mass that flows through Washington and that affects Kamiak Butte is the marine polar air mass. The marine polar air masses are cool, moist air masses. This air mass originates from the continental polar air masses in Asia and polar regions. This marine polar air mass heavily affects the Cascade Mountains and the west side of Kamiak Butte. Macroclimate is the broad-scale climate of a large region within a continent. The macroclimate that Kamiak Butte is in is the marine-modified continental macroclimate. This macroclimate includes a large portion of the west coast. Since the Palouse isn't too far inland, the weather is more temperate than a more inland region within the same macroclimate. The Palouse is also close enough to the ocean that the marine polar air mass has some effect on the region, but not as much if there wasn't a geologic barrier separating the west and east side of Washington, which is the Cascade Mountain Range. Continentality refers to the distance from the ocean. To be exact, continentality refers to the variation in temperature and climate due to the range between a location and the ocean. Although Washington has coastline, the eastern side of Washington has an exaggerated continentality because the Cascade Mountains block the ocean's effect on the region. The temperature on the west side of Washington is much more exaggerated due to the exposure to the ocean climate. Topography refers to the configuration of land surfaces and the points of relief in a location. Kamiak Butte is cooler and more moist than other areas of the state due to the rain shadow cast of the Cascade Mountains. Kamiak Butte's topography also displays its own rain shadow effect. This creates different precipitation amounts comparing the north and the south side of the butte. The rain shadow effect is in full effect at Kamiak Butte. The process of the rain shadow effect starts with an air mass that cools over the land. Then, as air rises due to elevation, the air becomes colder, causing condensation of water vapor, leading to precipitation. As the air mass reaches the top of Kamiak Butte, it begins to descend down the lee side of the mountain, and the gravitational pull results in the air mass being pulled back to the Earth's surface. The descending air mass on the lee side of Kamiak Butte warms as it descends, and as the air mass warms, it is more capable of holding water as vapor, producing significantly less precipitation, resulting in a rain shadow. Kamiak Butte presides in the marine-modified continental climate. Even this macroclimate is modified because of the protection from ocean winds and rains by the Cascade Mountain Range. This results in the Palouse being a drier region than other parts of Washington. The rain shadow also shows different vegetation growth between the two sides of the mountain. The north-facing side is flourishing with plant and tree life, while the leeward side is dry and not capable of maintaining plant life. Kamiak Butte is a prime representation of the North America Western Interior shrublands and woodland biome. On the northern side of the butte, the woodland is more successful because of less strain from solar radiation than the southward side of the butte. The climate, vegetation, and weather on this side of the mountain is more sustainable for a woodland environment. The southward-facing side has so much strain placed on it by solar radiation and lack of shade, it is hard for plants and trees to grow on it. Wind is also an extreme factor that restricts a woodland environment because the young plants have no barriers to protect them, so they don't have a chance to grow. There's a drastic change between the two sides of the butte. One, a thriving woodland, and the other, a barren shrubland looking over agricultural land. Each aspect of Kamiak Butte has an interesting physical site characteristics. In the next two slides, I will individually dive deeper into each aspect. The north aspect is much vaster with vegetation than the south aspect. The north side is rich in Douglas fir, ponderosa pine, and western larch. This large number of trees create a rich ecosystem and productive canopy coverage. The north aspect also has a rich understory vegetation that brings life to the butte and creates moisture and nutrients to provide pristine growing conditions. The south aspect of the butte is much different than the north. I describe it as barren and open with little vegetation life. The south aspect only hosts ponderosa pine, but even these trees have different attributes than the north aspect. They grow much shorter on the south side and are much less abundant. The south aspect only has 35 trees per acre compared to the north's 158 trees per acre. The south aspect also doesn't host much understory vegetation life and has much drier soil that is less nutrient-rich. The two aspects of the butte have many differences within their communities, whether it's species, species diversity, species abundance, or vegetation. These differences have existed since the formation of the butte because of its structure and how each side receives solar radiation and precipitation. The next two slides will address the differences between the two aspects' forest communities and wildlife. The north aspect is much livelier with vegetation and wildlife. The north side has more vegetation that is helpful for herbivores that then lead to predators being attracted to the area. The wildlife is much more diverse on this side of the mountain. The moose and red-tailed hawk are very limited species in the area, but this side of the butte sustains the need for these species and other common species to the area like squirrels, mule deer, coyotes, white-tailed deer, and even possibly cougars. There are a few species that occupy this side of the mountain, including mule deer, white-tailed deer, and turkeys, due to the south aspect having limited resources compared to the north aspect. There is a lack of understory vegetation, and that could be caused by many factors like the amount of solar radiation or lack of precipitation the south side receives. Although it seems barren and lacking wildlife, the south aspect still thrives even with limited resources and is part of a unique ecosystem that Kamiak Butte stands to be. Thank you for watching my video on Kamiak Butte and all of its wonderful history and treasures it has to offer.